Imagine meticulously documenting a personal scientific experiment for almost 1,000 days.
Oh, wow. Yeah, that is a massive commitment.
Well, right. I mean, you're recording data, you're tracking changes, basically building this massive archive of observations.
Yeah, day in and day out,
Exactly. And then one day you realize the most critical piece of information you've been waiting for, it can't actually be seen. It can only be heard.
which is just wild because it completely flips the script on how we think about observation.
Totally.
We are so conditioned to, trust our eyes and our calendars, but nature often operates on an entirely different sensory frequency.
It really does. So today on the deep dive, we are taking a really close look at a single short journal entry. It was published on August 15th, 2026, by an author known simply as Ang.
Just dang.
Yep, just Ang. And the entry is titled Notes on Gardening, Part 987, the actual timing for peacock flower seeds harvesting. And the scientific name is caesalpinia-pulcherrima, if I'm saying that right.
You got it. It's a bit of a mouthful, but
Okay,
yeah.
good. So on the surface, you might read that title and think, oh, it's just a mundane backyard update, a couple of sentences about a plant.
Right, like a basic gardening blog.
Exactly. But when you really unpack what Ang is describing, it turns into this fascinating masterclass on, like, the unpredictability of nature and the mechanics of how we actually learn to read the physical world.
Yeah, and to really understand why Ang's realization is so interesting, we have to start by looking at the sheer scale of the project.
Oh, absolutely.
Because this isn't just a casual weekend gardener. Ang starts the entry with, "Dear interweb," continues from my previous post, and then drops that massive number.
Part 987.
Part 987. I mean, that's just incredible dedication.
That number is wild to me. Approaching 1,000 documented entries implies a level of rigor that you usually associate with, like a laboratory, not a backyard garden.
Exactly. It frames the entire text differently, I think.
It does. It means Ang isn't just growing flowers, they're building a longitudinal data set.
Yeah, and there is actually a specific scientific term for what Ang is doing here. It's called phenology.
Phenology. Okay, what is that exactly?
So phenology is the study of cyclic and seasonal natural phenomena, especially in relation to climate and plant life.
Oh, okay. Like tracking when things bloom and stuff.
Exactly. When you think of historical records, like the famous journals tracking the Kyoto cherry blossom blooms, those go back over 1,000 years.
Oh, right. I've heard of those.
Yeah, or like Henry David Thoreau's meticulous records of when the ice melted on Walden Pond. That is phenology.
Wow. So Ang is basically in that same tradition.
Yes, it's about tracking the rhythms of nature over long periods of time. So by reaching part 987, Ang is essentially acting as a citizen scientist. They're contributing to a micro-level phenological record.
That is so cool. So they are tracking the rhythms, but what's funny is that in this specific entry, the rhythm completely threw them off.
Oh, it really did.
Let's look at the plant in question, the peacock flower. What are we actually dealing with here, botanically speaking?
Well, the caesalpinia-pulcherrima is a really striking plant. It's often called the pride of Barbados.
Pride of Barbados. Okay.
Yeah, it's a shrub or a small tree in the legume family, which, by the way, is a super important detail for later.
Okay, noted. Legume family.
Right. And it produces these incredibly vibrant, fiery red, orange, and yellow flowers. But because it's a legume, like a pea or a bean, once those beautiful flowers are pollinated, they develop into these flat seed pods.
Got it. And Ang's goal in this entry is simply to harvest those pods, right, at the perfect moment of maturity so they can plant more of them.
Yep, the goal is propagation.
Okay, so because Ang has this massive database of 987 entries, they do what any good data scientist would do.
Look at the historical data.
Exactly.
Yep.
They look at their records to predict the future. The text explicitly references an order post, part 877, to figure out how long it should take for these specific seed pods to mature.
Which makes sense. They are using past data to establish a baseline hypothesis for the current batch. I mean, it's just the textbook application of the scientific method.
It is. But the data is a little weird, and this jumped out at me immediately when I read it.
Oh, the timeline issue.
Yeah, the timeline. Because based on part 877, Ang writes, this roughly took around 3 months, or 6 to 8 weeks, for the seeds to mature and be ready for harvesting.
Yeah, that math is definitely a bit fuzzy.
Right. Now, wait a second. 6 to 8 weeks is about a month and a half to 2 months. 3 months is 12 weeks.
Right, yeah.
Those are two radically different blocks of time. It's a massive margin of error. When I first read that, I thought, is garden time just like contractor time?
Tractor time.
You know, when they say they'll finish your kitchen in 6 weeks, but they really mean 3 months, and the calendar just like bends to their will.
That's a funny way to think about it. But in reality, it's almost the exact
It's
opposite.
really, how so?
Well, a contractor might be disorganized, but a plant is actually executing a hyper-precise biological program.
Okay, so it's not just slacking off.
Yeah. No, not at all. It's just that the plant is using a completely different clock than we are. When Ang notes that massive discrepancy between 6 to 8 weeks and 3 months, they're bumping up against a concept in agriculture known as growing degree days, or GDD.
Growing degree days, how does that work?
So we humans measure time in 24-hour solar cycles.
Okay.
Right. Monday, Tuesday, Wednesday.
Human time.
Exactly. But plants do not care what day of the week it is. They track heat accumulation.
Heat accumulation?
Yeah. A growing degree day is a measure of heat accumulation used by horticulturists to predict plant and animal development rates. Every plant has a base temperature below which it simply will not grow.
Oh, interesting.
So if it's a cold, overcast week, the plant might log 0 growing degree days. The calendar weeks still pass for the human, but chronologically, the plant didn't age a single bit.
Oh, wow. That makes total sense. So if Ang had a stretch of really hot sunny weather, the peacock flower might hit its required heat accumulation in like 6 weeks. But if they had a cooler, cloudier season, it might take a full 3 months for the exact same biological process to finish.
You hit the nail on the head. The discrepancy in Ang's notes isn't bad math. It's actually an accurate reflection of microclimates and weather variations.
Ah.
The mistake Ang made wasn't the math. The mistake was trusting the human calendar over the physical condition of the plant. They relied on this abstract timeline.
And the plant rebelled against the timeline in a pretty dramatic way.
It sure did.
Because Ang was just waiting. The text implies this, like passive expectation. They were waiting for the weeks to tick by on the calendar. And then Ang writes, "Little did I know, some of the seeds had reached maturity and split open."
Yeah, that's rough.
It's a very humble admission for someone with hundreds of journal entries, but I want to dig into that phrase, split open, because when you look at a seed pod, it looks like a pretty solid sealed container.
Oh, they are. They're very tough.
Right, so how does it just spontaneously split?
Well, this is where being a legume becomes really important, like I mentioned earlier. The peacock flower pod undergoes a process called dehiscence, specifically explosive dehiscence.
Explosive dehiscence. That sounds like a heavy metal band name.
It really does, yeah.
But what is it botanically? Are they actually exploding?
Botanically speaking, it's the plant's built-in mechanism for seed dispersal. So when the pod is green and growing, it's full of moisture.
Okay.
But as the seeds mature, the pod begins to dry out. The technical term is desiccation. And here's where the engineering of the pod is just brilliant.
Oh, I love plant engineering.
Right, so the walls of the pod are made of different layers of cells that dry and shrink at completely different rates.
Wait, really? So the outside layer might be shrinking faster than the inside layer?
Precisely. And because these layers are fused together, this differential shrinking creates immense mechanical tension. The pod is essentially winding itself up like a tightly coiled spring.
Oh, wow. So to the human eye, looking at it from the outside, it just looks like a pod slowly turning brown.
Yeah, you can't see the tension building.
That's sneaky.
It is. But eventually, the tension becomes too great for the structural integrity of the pod's seam, and the seam violently snaps open. The two halves of the pod twist backward, literally launching the seeds out into the surrounding soil.
That is incredible. So Ang wasn't just slightly late. By the time the pod splits, the whole operation is over. The payload has been deployed.
Exactly.
It's not like fruit where it just gets a little overripe and socked and you could still kind of use it.
Yeah.
If you miss the window with explosive dehiscence, the seeds are just gone, scattered in the dirt.
Right. They're everywhere. If your goal is to harvest them, you have to intercept the pod at the exact moment it's fully mature, but just before the mechanical tension reaches the breaking point.
That sounds like a really narrow window.
It's a very narrow window.
Which perfectly explains why Ang realizes they need a better testing method. I mean, the calendar is too variable because of the growing degree days.
Yep.
And visual observation is useless because you can't see the mechanical tension building up inside the pod. So Ang discovers what they call the sound test.
The sound test.
Yeah, and this is the pivot in the journal entry that really captured my attention.
It's a brilliant shift, really, from passive observation to active interrogation.
Yes, exactly. Let me read Ang's exact realization. They write, "For more accurate timing, I should have done the sound test, where given a little shake, you should heard some rattle sound indicating the seeds have mature and disconnected from the inner wall."
It's such a simple, elegant solution.
It really is. It reminds me of those, sensory tricks you learn just by living in the world,
Oh, like what?
like tapping the bottom of a loaf of sourdough bread. If it sounds hollow, you know the crumb structure has set and the moisture has baked out properly.
Oh, yeah, that's a classic one.
Or like lightly squeezing an avocado, you can't just look at it, you have to interact with it to gather the data.
The bread analogy is actually very apt here.
Really?
Yeah, because both involve measuring internal moisture and structural changes through sound. But the biology of what Aang is hearing, that rattle sound, is deeply specific to the life cycle of the seed.
Okay, let's break down the biology of the rattle then. Why is it rattling now when it wasn't rattling a week ago?
So Aang specifically notes that the rattle indicates the seeds have, quote, disconnected from the inner wall. That disconnection is an actual physiological event called abscission.
Abscission.
Yes. When a seed is developing, it is physically attached to the pod by a tiny botanical umbilical cord called the funiculus.
Wait, really? A botanical umbilical cord?
Yeah, that's exactly what it functions as. This is how the mother plant pumps water and nutrients into the seed while it's growing.
So as long as it's growing, it's literally tethered to the wall of the pod.
Yes, it is firmly anchored down.
Yeah.
If you shake a green pod, you hear absolutely nothing.
Because they're locked in place.
Exactly. They're locked in place and swollen with moisture. But when the seed reaches full biological maturity, it doesn't need the mother plant anymore.
It's ready to go.
Right. It seals off that connection. The funiculus dries up and breaks, and the seed is now physically autonomous inside the pod.
Oh, wow. And it's not just the disconnection, right? Because the seed itself is drying out. Does it also shrink a bit?
You're exactly right. The seed loses a significant amount of water weight, shrinking down and becoming quite hard. And simultaneously, the pod around it is also drying and creating a small, hollow cavity.
So it's basically a maraca at that point.
Pretty much.
Yeah.
You have a hardened, autonomous seed sitting inside a hollow acoustic chamber.
Yeah.
That is what creates the rattle.
That is just stunning. The rattle is literally the sound of biological independence.
It's a poetic way to put it, but it's true.
It's the sound of a seed that is completely ready to survive on its own. If it doesn't rattle, it means it's still dependent, it's still taking resources. But Aang figures out that the ultimate test of maturity is listening for that unseen separation.
It's a massive paradigm shift for a gardener.
Yeah.
Aang has realized that time, weeks, months, days, was the entirely wrong metric to track. The correct metric is autonomy. And you can only measure that by stepping in, touching the plant, and listening to how it responds.
It makes you wonder how many times they just stared at those pods, just willing them to be ready when all they had to do was flick them with a finger.
Probably a lot.
But what I love about this journal entry is that Aang doesn't spend any time dwelling on the seeds that were lost to the explosive split.
No, not at all.
There's no agonizing over the mistake. They immediately pivot to application.
Yes, the cycle of iteration. This is where the discipline of writing 987 journal entries really pays off.
How so?
Well, a less experienced gardener might get frustrated and just quit for the season, throw their hands up. But Aang processes the failure, extracts the data, which is the sound test, and applies it in real time.
Yeah, because Aang notes that the seeds they did manage to harvest are for the next batch of propagation. But the crucial line is how they frame the new lesson.
Right.
They write, "This is something worth noting for the next batch of flowers blooming right now."
Blooming right now. I love that.
I find that phrase incredibly energizing. It's not some vague promise to do better next year or next season. The plant is continually producing new flowers, which means it's continually producing new test subjects.
It's a wonderful biological parallel to, agile development.
Oh, in software.
Yeah. In software, if you find a bug, you don't wait for a massive annual release to fix it. You push a patch to the live environment immediately.
That's such a good comparison.
Nature has its own built-in iteration cycles. The peacock flower isn't just producing one single cohort of seeds, it's staggering them.
Right.
It's providing an environment where Aang can test this new acoustic hypothesis, the sound test, almost immediately on the adjacent branch.
It strips away all the theoretical baggage. It's just, hypothesis failed, timeline was wrong, structural mechanism understood, new sensory test developed, apply test to branch number 2.
Exactly. It's rapid prototyping in the garden.
And there's a real quiet optimism to that process. You can feel it in the way Aang signs off the entry. Just simply, till the next post. Yours truly, Aang.
It's the implicit promise of a Part 988.
Yes.
When you view your work through that lens as an ongoing, numbered series of observations, Failure completely loses its sting. The seed splitting open early wasn't a disaster.
No, it was just data.
Exactly.
Yeah.
It was simply the necessary catalyst to understand the limits of the calendar and the necessity of the rattle.
The failure of the abstract timeline was the prerequisite for discovering the physical truth.
Precisely. You can't learn how to read the landscape if you never look up from the map.
Oh, I like that.
Or in Eng's case, you can't learn to hear the rattle if you never look away from the calendar.
And that journey, from the map to the landscape, from the calendar to the physical object, is what makes this short journal entry so universally applicable.
I completely agree.
You don't have to know a single thing about caesalpinia-pulcherrima to understand what Eng is going through here.
Not at all.
We started by looking at the monumental dedication it takes to track a process nearly 1,000 times. We explored the concept of phenology and how the natural world just ignores our human obsession with neat, uniform weeks and months.
Right, relying instead on the quiet accumulation of heat and microclimates.
Exactly.
And we unpacked the incredible mechanical tension of explosive dehiscence, and why visual observation is often totally inadequate for processes that build up pressure invisibly over time.
And then we got to the breakthrough, the sound test, the realization that true maturity, that final severing of the connection, it can't be seen, but it can be heard if you know how to interact with it.
If you know how to give it a gentle shake.
Right. It's a shift from waiting passively to testing actively.
And ultimately, it's about the resilience of immediate application. Not pushing the lesson off to some distant future, but applying it to whatever's blooming right now.
It really is a masterclass in how to pay attention to the world. So as you go back to whatever it is you are working on today, whether you're managing a complex team project, waiting for an investment to mature, or literally just trying to harvest something in your own backyard, I want to leave you with a thought to mull over.
Yeah, that's a good one.
Eng had nearly 1,000 days of historical data, and they still had to abandon their calendar and listen for the tiny rattle of a disconnected seed to know the plant was actually ready. So, what other processes, projects, or even relationships in your life might have a hidden sound test? What unseen indicator of maturity or readiness are you currently missing entirely simply because you're too busy staring at the calendar and waiting for the weeks to tick by? Sometimes you just have to give things a little shake to hear where they're really at. Thanks for joining us on this deep dive. Stay curious, keep iterating, and we'll see you on the next one.